Hey everyone, welcome, I am Amjith, and today I am gonna share with you hydraulic actuating system. It uses fluid power to produce mechanical force. Fluid power is technology that deals with the generation, control and transmission of forces responsible for movement of mechanical element. The fluid used in hydraulic actuator is highly incompressible so that pressure applied can be transmitted instantaneously to the member attached to it. Hydraulics is based on Pascal's law, which states that when there is an increase in pressure at any point in a confined fluid, there is an equal increase at every other point in the container. Pressure applied to a confined fluid at any point is transmitted undiminished and equally throughout the fluid in all directions and acts upon every part of the confining vessel at right angles to its interior surfaces. In simple words, intensity of pressure in fluid is equal in all direction. Hydraulic actuators are used where high speed and large forces are required. Various components of hydraulic actuators are given in brief below. Pump. Hydraulic power generation system. Pump pressurizes fluid to the level required by an actuating system. Valve controls the direction, pressure, flow rate of hydraulic fluid. It basically acts as a regulating system. Actuator converts the fluid pressure into mechanical movement, either linear or rotary. Pipes used to connect various elements of actuating system with each other. Accumulator, reservoir and filter. Filter is used to filter the hydraulic fluid to prevent damage to system components by contaminants. Reservoir and accumulator is used for storage purposes. Sensors, crucial part of any automation process. Provide some kind of feedback signal to evaluate the end result by controller. Control device, control whole actuating system by providing signals. Microcontroller or PLC are popularly used. Hydraulic actuators, as used in industrial process control, employ hydraulic pressure to drive an output member. The fluid used in hydraulic actuator is highly incompressible so that pressure applied can be transmitted instantaneously to the member attached to it. A hydraulic actuator consists of a cylinder or fluid motor that uses hydraulic power to facilitate mechanical operation. The mechanical motion gives an output in terms of linear, rotary or oscillatory motion. Because liquids are nearly impossible to compress, a hydraulic actuator can exert considerable force. Principle used in hydraulic actuator system. Pascal's law, pressure applied to a confined fluid at any point is transmitted undiminished and equally throughout the fluid in all directions and acts upon every part of the confining vessel at right angles to its interior surfaces. Amplification of force, since pressure P applied on an areaway gives rise to a force F. Thus, if a force is applied over a small area to cause a pressure P in a confined fluid, the force generated on a larger area can be made many times larger than the applied force that created the pressure. This principle is used in various hydraulic devices to such hydraulic press to generate very high forces. Hydraulic actuators are of three types. Linear actuator, single acting cylinder, double acting cylinder. Rotary actuator, oscillatory actuator, linear actuator, single acting cylinder. In single acting cylinder actuator, there is only one opening for the fluid to enter and leave. The forward motion is due to the hydraulic pressure of the fluid entering through the opening, while the reverse motion is due to the spring. Double acting cylinder. In double acting cylinder actuator, there are two openings for the fluid to enter and leave. The forward motion is due to the hydraulic pressure of the fluid entering through one opening, while the reverse motion is due to the hydraulic pressure of the fluid entering through one opening. Rotary actuator. In rotary actuator, the linear motion of fluid inside the pipe is converted into rotary motion by a hydromotor. Components of hydraulic actuation systems. Hydraulic fluid. Hydraulic fluid transmit the fluid power from the reservoir to the actuator cylinder. Hydraulic fluid must be essentially non-compressible to be able to transmit power instantaneously from one part of the system to another. It should lubricate the moving parts to reduce friction loss and cool the components so that the heat generated does not lead to fire hazards. It also helps in removing the contaminants to filter. The other desirable property of oil is its lubricating ability. The fluid also acts as a seal against leakage inside a hydraulic component. The most common liquid used in hydraulic systems is petroleum oil because it is only very slightly compressible. The fluid delivery subsystem. It consists of the components that hold and carry the fluid from the pump to the actuator. It consists of reservoir, filter, line, fittings and seals, pump, motor, accumulator etc. Reservoir. It holds the hydraulic fluid to be circulated and allows air entrapped in the fluid to escape. This is an important feature as the bulk modulus of the oil, which determines the stiffness of hydraulic system, deteriorates considerably in the presence of entrapped air bubbles. It also helps in dissipating heat. The hydraulic fluid is kept clean in the system with the help of filters and strainers. It removes minute particles from the fluid, which can cause blocking of the orifices of servo valves or cause jamming of spools. Line. Pipe, tubes and hoses, along with the fittings or connectors, constitute the conducting lines that carry hydraulic fluid between components. Lines convey the fluid and also dissipate heat. Lines are one of the disadvantages of hydraulic system that we need to pay in return of higher power to weight ratio. They need return path. In contrast, for pneumatic systems, no return path for the fluid, which is air, is needed, since it can be directly released into the atmosphere. There are various kinds of lines in a hydraulic system. The working lines carry the fluid that delivers the main pump power to the load. The pilot lines carry fluid that transmit controlling pressures to various directional and relief valves for remote operation or safety. Drain lines carry the fluid that inevitably leaks out to the tank. Fittings and seals. Various additional components are needed to join pipe or tube sections, create bends and also to prevent internal and external leakage in hydraulic systems. Although some amount of internal leakage is built in, to provide lubrication, excessive internal leakage causes loss of pump power since high pressure fluid returns to the tank, without doing useful work. External leakage, on the other hand, causes loss of fluid and can create fire hazards, as well as fluid contamination. Various kinds of sealing components are employed in hydraulic systems to prevent leakage. Hydraulic pumps. The pump converts the mechanical energy of its primed mover to hydraulic energy by delivering a given quantity of hydraulic fluid at high pressure into the system. Generically, all pumps are divided into two categories, namely, hydrodynamic or non-positive displacement and hydrostatic or positive displacement. Hydraulic systems generally employ positive displacement pumps only. Hydrostatic or positive displacement pumps. These pumps deliver a given amount of fluid for each cycle of motion, that is, stroke or revolution. Their output in terms of the volume flow rate is solely dependent on the speed of the primed mover and is independent of outlet pressure notwithstanding leakage. There are various types of pumps used in hydraulic systems such as gear pumps, vane pumps, piston pumps, radial piston pumps etc. Motors work exactly on the reverse principle of pumps. In motors, fluid is forced into the motor from pump outlets at high pressure. This fluid pressure creates the motion of the motor shaft and finally go out through the motor outlet port and return to tank. All three variants of motors, already described for pumps, namely gear motors, vane motors and piston motors, are in use. Accumulators. Unlike gases, the fluids used in hydraulic systems cannot be compressed and stored to cater to sudden demands of high flow rates that cannot be supplied by the pump. An accumulator in a hydraulic system provides a means of storing these incompressible fluids under pressure created either by a spring or compressed gas. Any tendency for pressure to drop at the inlet causes the spring or the gas to force the fluid back out, supplying the demand for flow rate. There are two types of accumulators: spring-loaded accumulators, gas-charged accumulator. Cylinders. Cylinders are linear actuators, that is, they produce straight line motion and/or force. Cylinders are classified as single or double acting with the graphical symbol for each type. There are two types of cylinders such as single acting cylinder and double acting cylinder. Advantages of hydraulic actuator systems. Variable speed and direction. The actuator, linear or rotary, of a hydraulic system, can be driven at speeds that vary by large amounts and fast. By varying the pump delivery or using a flow control valve. A hydraulic actuator can be reversed instantly while in full motion without damage. This is not possible for most other prime movers. Power to weight ratio. Hydraulic components, because of their high speed and pressure capabilities, can provide high power output with very small weight and size. Stall condition and overload protection. A hydraulic actuator can be stalled without damage when overloaded, and will start up immediately when the load is reduced. The pressure relief valve in a hydraulic system protects it from overload damage. During stall, or when the load pressure exceeds the valve setting, pump delivery is directed to tank with definite limits to torque or force output. Hydraulic actuators are rugged and suited for high-force applications. They can produce forces 25 times greater than pneumatic cylinders of equal size. They also operate in pressures of up to 4,000 pounds per square inch. Hydraulic motors have high horsepower to weight ratio by 1 to 2 horsepower per pound greater than a pneumatic motor. A hydraulic actuator can hold force and torque constant without the pump supplying more fluid or pressure due to the incompressibility of fluids. Hydraulic actuators can have their pumps and motors located a considerable distance away with minimal loss of power. Drawbacks. Hydraulics will leak fluid. Like pneumatic actuators, loss of fluid leads to less efficiency. However, hydraulic fluid leaks lead to cleanliness problems and potential damage to surrounding components and areas. Hydraulic actuators require many companion parts, including a fluid reservoir, motors, pumps, release valves, and heat exchangers, along with noise reduction equipment. This makes for linear motions systems that are large and difficult to accommodate.